Hello everyone. The title of this video is Graph Exponential Functions. Each exercise I'm going to do in this video is taken directly from a free online textbook at openstacks.org. I'm in their Intermediate Algebra 2nd edition text. And I'm in section 10.2, which is titled Evaluate and Graph Exponential Functions, and I'm working under the heading Graph Exponential Functions. I'm only going to be doing the even numbered exercises, the ones that do not have links to solutions, right? The odd numbers have links to solutions, so I'm not doing those, right? So I'm doing 66, 68, 70, all the way down to 94 for this video. I will also have timestamps for each of these examples in the description of the video. So if you look in the video description below, you'll see example 1, right? That timestamp will be for the beginning of number 66. Example 2 will be for 68. Example 3 for 70, and so on. All right. I also request of you that when I start a new question, pause the video and try to work on it yourself first before watching me do it and comparing. Because if you're just watching me do these questions, without practicing yourself, chances are you're not going to learn all that much. Alright, so the first question, and in this first set of exercises, we have the instructions, graph each exponential function. Alright, so I'm starting with 66. I have these written out. Okay, so this is example 1, exercise 66 from the text. And we're given the function g of x, right, or y, equals 3 to the x power, right? The reason these are called exponential functions is because the input variable, right, in this case it's x, is in an exponent, right? It's in a power on some base. Here the base is 3 and the exponent is x. Well, I'm going to graph these in the same way I graph any function, right, in the beginning. We're going to make a table with inputs x and outputs, called g of x, or y coordinates if you want to call them y. And I'm just going to plot a bunch of points. Right. So to start, I'm going to plug in the values from -2 to 2. -2, I'm going to plug in the integers. Now you don't have to plug in integers. You can plug in any real number you wish. But integers are usually easier to evaluate a function at. So -2, -1, 0, 1, and 2. Let's start with those 5. Alright, so I'll start with 2. Alright. So 3 to the second power. Alright, putting in 2 for x. G of 2 would be 3 to the 2, that's 3 times 3, that's 9. Alright, so on the graph, I'm going to make a rough sketch over here on an xy plane, x-axis, y-axis. We have 2 on the x input, 9 on the y. Alright, and this might not be great looking, but I'm doing the best I can by hand. And then I will, I'll go to an online graphing calculator at that desmos.com website and show you a much better picture of the same function. So there's the ordered pair, 2, 9, input 2, output 9. All right, so that point is on the graph, satisfies this function, belongs to this function g. All right, then 3 to the 1, right, replacing x with 1. Well, 3 to the first is just 3. Right? Anything to the first power is just itself. So 1, 3. Right? Input 1, output 3. There's this point. All right. Now, this tends to trick a lot of people the first time they see it. If I plug in 0 for x, 3 raised to the 0 power is not 3 times 0. Right? This is not 0. Follow the pattern here. See that 3 to the second was 9. I decrease the power by 1. All that does is divide the output by 3. Right? 9 divided by 3 is 3. So do the same thing here. Decrease the power by 1. The output gets divided by 3. 3 divided by 3 is 1. And this is something you're going to notice, is that any non-zero number raised to the 0 power will be 1. Right, so I have 0, 1. Input 0, output 1. Right, there's the y-intercept of this graph. Right, and then I keep going with that pattern. If I plug in -1 for x, right, 3 to the -1 power, again, this is not 3 times -1. This is 3 raised to the -1 power. So I decrease the power by 1. You divide the input by 3. That'd be 1/3. And you notice how 3 to the -1 is 1/3, and 3 to the +1 is 3. Those are reciprocals. That will always happen with negative powers and positive powers. Negative powers are just the reciprocals of their positive powers, of their corresponding positive powers. So 3 to the second is 9. That means that 3 to the -2, 3 to the -2, is 1/9, positive 1/9. Notice that these are not negative outputs. Alright, so we have -1 input, and then positive 1/3. I'm going to eyeball this. So -1 input, 1/3 output. There, still above the x-axis. Right, and then -2 input, 1/9. Right, 1/9, really tiny. Right, really tiny, 0.111111. So -2 input, positive 1/9 output, still above the x-axis, even though it's barely above. And that's going to continue on. All right. Now I have these 5 points. We can make a rough sketch of the rest of the graph. All right. Show you the rest of the graph here. So from this point 0, 1, again, it's very curvy. Just curves upward, upward. And then if I were to plug in 3, right, 3 to the 3rd power is 27, right? This is shooting up quite quickly, right? So a little arrow at the end there. But going the other way from the point 0, 1, it's going down, but very slowly. -1, 1/3, -2, 1/9. And if you were to plug in -3, right, 3 to the -3 would be 1/27th, positive 1/27th. And no matter what you plug in to the left here, it's going to always be above the x-axis for this particular function. Little arrow, it's going that way forever, but it's getting closer and closer and closer to the x-axis without ever actually touching it. Alright, so we're going to call the x-axis here a horizontal asymptote. You may have heard that word before. Do a little dotted line on the x-axis here. This is a horizontal asymptote, and every single one you're going to notice throughout this video, every single one of these exponential functions is going to have some horizontal asymptote. All right, this is again it's just a horizontal line, which is y = 0 here, right? The x-axis. Y = 0, same thing. It's just a horizontal line that the graph will approach but never actually become. Right? The graph gets closer and closer to it as we move to the left, but it never actually becomes, or touches the x-axis. Okay, and there we go. There's the graph of this function. Now I'm going to point out a few things, right? One of the things I just pointed out was we have a horizontal asymptote. Some other things about this function here is, as x increases, y increases all the time, right? It's always going up as I move to the left. So they would call this an increasing function. This is an increasing function. Again, all that means is that as I go to the right, the y values are always going up. Another point I want to make, another property we're seeing here is that the domain, right, you should be talking about, the domain and range of any function you draw. Right, the domain is, right, all the x coordinates used. Notice, I can plug in anything for x. Any value of x is going to give me a point on this graph. So the domain is all real numbers, and this will be the case for any exponential function. And the function will either be increasing or decreasing. Right? It's either going to go up as you go left to right, or it's going to go down as you go left to right forever. But it depends on what function you're looking at. The range of this function. Remember, that's the y coordinates, right, or the g coordinates. Right? This is the function g. Notice, again, the y coordinates are all positive. So they're above 0, not including 0. Right? So from 0 up, from 0 to infinity, right? From the horizontal asymptote upward. Not including 0, though. So notice I have parentheses on 0 here, and always parentheses on infinity. There's the interval notation for your domain and range. And again, there's always there's going to be a horizontal asymptote for all of these exponential functions. It just might move around depending on what function you're looking at. All right, so you're going to have some sort of horizontal asymptote that the graph will get closer to but never touch. The graph will either be an increasing function, right, going up as you move from left to right, or it will be a decreasing function, meaning going down as you move from left to right. The domain for any exponential function will be all real numbers. You can plug in anything you want, any real number, any x value for any exponential function. It's the range that's a little tricky. The range is just every value either above or below the horizontal asymptote. Again, it all depends on the way the function looks. But the horizontal asymptote, right, will be key in determining the range. Wonderful. All right, so let me also put out those properties of exponents that will be useful. Properties that we saw here with the number 3. Some properties of exponents that will be useful as you graph exponential functions by hand. One of those is if you take a number that's not 0 and raise it to the 0 power, that value is 1. Right, again, as long as the number is not 0. Right? 0 to the 0 power is something totally beyond the scope of this intermediate algebra course. Right? But yeah, so 3 to the 0, right, was 1. And also the negative powers, right? Anything raised to a negative power, right, b to the negative n, is just the reciprocal, right, 1 over the positive power, right, b to the n. And again, b is not 0 here, because you can't have 0 in a denominator. Right, so these should be important. Right? You should remember these when evaluating these functions. Right? And once again, these are key. Right? And we're going to talk about these 3 things, and also what the horizontal asymptote is for any of these exponential functions. We're going to say, is it increasing or decreasing? The domain will always be all real numbers, so no need to worry about that too much. And then what's the range? Do I have all the values above, all the y values above the horizontal asymptote, or all values below the horizontal asymptote? Okay, So that's a lot of stuff, a lot of stuff. All right, and then like I said, I'm going to go to the Desmos website. All right, there's a free online graphing calculator at desmos.com. And I will enter this function and also the horizontal asymptote. We were given g of x equals 3 to the x power. And look at this here. I can add a table to this, right? Add a table, and it points out some points here. See? There's -2. Now see, it's 0.111111111. That's 1/9 as a decimal. And then here's -1.333333. Right? That's 1/3 as a decimal. We plotted those on our graph by hand. Here's 0, 1, right? 1, 3. And you see in the table 2, 9, right? 3, 27, and so on. Now notice, all right, let me get rid of the table now. All right, now let me put in the y equals 0, right? The x-axis, and I'm going to make that a dotted line because it's not actually part of the graph of the exponential function. And you see this is our horizontal asymptote. Now I know from here it looks like our red graph is hitting this. But if you zoom in, just scroll in, you scroll in far enough, you'll see that the graph actually doesn't touch the x-axis, ever. Go as far left as you want. The red graph will always be above the x-axis, y equals 0. And let me go back to the home. And it's increasing, right? Just pick any point. As I go to the right, the y values are going up. Right? As x increases, y increases. The domain is all real numbers, and the range, right, is only values that are positive. Right? Now I know it says 0 here, but it's not 0. Right? It's just so close to 0 that it says it's 0. Right? The graph is never hitting the x-axis. But the range is all positive numbers. Right? Wonderful. All right, so let's go back to our pages. Next question. I'm going to do the same stuff. Right? Okay. Number 2, exercise 68. G of x equals 7 to the x power. Alright, so the same thing. I'm going to make a little table to start. X, g of x. And I'll plug in those same 5 integer values right now. -2, -1, 0, 1, and 2. And, 7 to the second is 49. 7 to the first is 7. 7 to the 0, remember any non-zero number to the 0 power is 1. And then 7 to the -1 is just the reciprocal of 7 to the first. So this was 7. That means this is going to be 1 over 7, positive 1/7. And 7 to the -2 power is the reciprocal of 7 to the 2 power. So that's 49. 7 to the -2 will be 1/49, right? Still positive. Still positive. And again, I'm going to make a little xy plane over here. And 0, and then 1, 2, and then -1, -2 on the x-axis. All right, now here's 1. I'm going to do this. I know it's not perfect, but let's say this is 7, and then 49 is up here, right? I don't have graph paper, and these aren't perfectly spaced. This is going to be actually terrible. And then 1/7, let's just say that's here, and then 1/49 is a 7th of that, right? 1/49, really tiny. But you're going to see a very similar graph to what I did in number 1 when we had y equals 3 to the x, right? You have 0, 1, 1, 7, 249. Again, this isn't a perfect graph, right? Negative 1, 1/7. Negative 2, 1/49. And notice as I go to the right, the values would get incredibly large, right? If you plugged in 3, 7 to the third power is 343. I mean, you're shooting up quite a bit, right? Very, very quickly. Right. Again, it's not straight. It should be curvier than that, but it's moving up so rapidly it might look straight. But then as you go left, all the values are still positive. 7 to the negative first is positive 1/7. 7 to the negative 2 is positive 1/49. 7 to the negative 3 is positive 1/343. And 7 to the negative a million is 1/7 to the million, still positive, right? So it doesn't matter how far left you go, the graph will never hit the x-axis. So once again, our horizontal asymptote is the x-axis, y equals 0. Right, the output's going to get as close to 0 as you wish without ever actually being 0. Right. And then once again, it is an increasing function. Right, as x increases, y goes up. Right, it's going up all the time as you move from left to right. So it's an increasing function. And then this is the case for every exponential function, but the domain is all real numbers, right? You can plug in anything you want for x. Your input can be any real number. It's the range that might be tricky, right? But the range here is the same as for number 1. See, every single y value here is above the horizontal asymptote, is above 0. So it's from 0 to infinity, right? It's all positive numbers, right? Not including 0. Notice again I have parentheses on 0. Again, I'll box this in. All right. And then once again, let me actually put this on the Desmos site. So instead of g of x equals 3 to the x, let's make that 7 to the x. And you're seeing the same kind of graph, but it's just shooting up more rapidly. I'll put a table in there for this function. And you see 0, 1, 1, 7, 249, right? If I put 3 here, 343. If I put negative 3, it's still positive, right? It's just very, very tiny, right? There's negative 2, that's 1/49th. The beginning of 1/49th as a decimal. Here's 1/7, the beginning of 1/7 as a decimal. And you're seeing all these points, that we plotted. Right, and then 1/7 is here, and then you could scroll up and get to 249, but you see it as you move to the right, it's going up real fast. As you move to the left, it's going down very, very slowly. And the x-axis, y equals 0. Right, I got y equals 0 here. This purple dotted line is still the horizontal asymptote, right? You can zoom in, zoom in, zoom in, zoom in, zoom in. Let's go. And you zoom in far enough, you'll eventually see that the red graph is above the x-axis all the time, and no matter how far left you go. Right? It's just hard to tell from here, right? But the red graph will always be above the x-axis, y equals 0. Okay. And it's increasing. Domain's all real numbers. Range is all positive numbers. Fantastic. Okay, let's look at the next question. And then after this next question, all right, I'm going to point out, questions 1 through 3 are all very similar in scope. So number 3, exercise 70, we have g of x equals 2.5 to the just the x power again. which if you want to write 2.5 as a fraction, that's 5 divided by 2, right? 5 halves. That's 2.5. So this is 5 halves to the x as well. And again, I'm going to make a table. Input, output, right? X and g of x. All right, and once again, I'm going to plug in -2 to 2. Just basic 5 inputs, 5 integer inputs. All right, now 5 halves to the second power, 2.5 to the second power, is 25 fourths. All right, 25 fourths, or 6.25. All right, 6 1/4, same thing. Then 5 halves to the first is 5 halves, right, or just 2.5, same thing as a decimal. And then 2.5 to the 0 power, right? 5 halves to the 0 power is 1. And then we have reciprocals, right? 5 halves to the -1 is just the reciprocal of 5 halves to the 1. And that was 5 halves, so flip that over. This is 2/5. But still positive, notice, right? Raising to negative powers doesn't make you negative. It's 2/5, or 0.4 as a decimal, but still positive. And then 5 halves, or 2.5, to the -2 is just the reciprocal of 5 halves to the +2. That was 25 fourths. So this is 4/25, which is 0.16, right, as a decimal. But positive, right? Notice it is still positive. All right, and then I'll make a graph by hand over here. All right, so we input 1, 2, and 0, and -1 and -2. And I'm just going to go 1, 2, 3, 4, 5, 6, 7. And yeah, let's say 0.4 is a little less than a half. Say there's 0.4, and 0.16, a little more than 1/10. I don't know. These would be tiny, right? All right. Okay, and then plotting some points now. Again, 0, 1 is on this. Cool. 1, 2.5. I guess I should have put 2 and 3 in there. Right? There's 2, there's 3. Here's 2.5, right? So input 1, output 2.5. Input 2, output 6 1/4. Sorry if you hear my dog barking. Then -1.4. Pardon me, I'm going to come back. Okay, and then input -2, output +0.16. And again, we have a very similar graph to the graphs of the first two that we have for 3 to the x and 7 to the x. Right? Starting from 0, 1 here, as you move right, the graph is going up rapidly, right, forever. But as you move left of that point, 0, 1, the graph is, slowly decreasing, but always positive. Still always positive, right? If you plug in -3, still positive. Plug in -4, still positive. Just very, very tiny, and getting closer and closer to 0. So once again, we have our horizontal asymptote of y equals 0. The x-axis, yet again. And once again, this is an increasing function, right? Because as I increase x, the y is, the output, the value of the function is always going up. So it's another increasing function. The domain is all real numbers. As I've been saying, this is always the case for an exponential function. Okay, you can plug in anything for x, And the range, right, the range is all positive numbers, right? Every value above the horizontal asymptote. So from 0 to infinity, but not including 0. Right? Right, so you see how very, very similar every single one of these first three questions was. We had a horizontal asymptote of the x-axis, y equals 0. Each of them was an increasing function, right, going up as I went from left to right. Domains all real numbers, ranges all positive numbers. So let me just write this in general, right? So our first three examples were y equals 3 to the x, 7 to the x, and 2.5 to the x. The way those looked was all very similar. So let me write this in general. Given y equals b to the x power, where b is the base and x is the exponent and that's the input, like 3 to the x, 7 to the x, 2.5 to the x, notice that all of those had a base bigger than 1, right? 3, 7, 2.5, right? Numbers 1, 2, and 3 all had a base bigger than 1. This is a basic exponential function. The graph will look like all those three graphs did. And again, b is bigger than 1, so let's say on the y-axis, say b is up here, and then 1 over b would be less than 1. Let's say there's 1 over b. And you'd have these points, the point 0, 1, right? B to the 0 would be 1. B to the 1 would be b, which is bigger than 1, right? So above 1 here. And b to the negative 1 would be 1 over b, right? The reciprocal. And then you plug in 2, you get b squared. Plug in 3, you get b cubed. Right? As I move to the right, the graph would just get larger and larger and larger very rapidly. Right? But then as I move left, the graph will get smaller, but slowly. And always be positive. Right? Plug in negative 2, you get 1 over b squared. Plug in negative 3, you get 1 over b cubed, and so on. Right? So all the properties we saw in the first three questions with 3 to the x, 7 to the x, and 2.5 to the x have the same properties as any basic exponential function with a base bigger than 1 will have. It'll have a horizontal asymptote at y equals 0, right, at the x-axis, because the graph will get closer to this without actually touching it as you move to the left. And it'll have those three properties that I mentioned for all those other three graphs. There'll be an increasing function, as x increases, the value of the function goes up, increases. The domain, and like I've been saying, this is for any exponential function. The domain is all real numbers. And the range is all the values, all the y values above the horizontal asymptote. So all positive numbers, right? So just from 0 to infinity, but not including 0. So yeah, so please get this in your head. Again, this is just for b to the x. Now, if the function looks any different, b to the negative x or b to the 2x plus 1, all bets are off, right? This is just for the basic b to the x, 1x function, right? And if b is bigger than 1, it's going to look like this in some way, right? An increasing function with a horizontal asymptote of the x-axis. Okay. Great. All right, so now the next examples, the base will not be bigger than 1. It'll still look like this. Y equals, b to the x power, simple number to a simple x power. But the base will be less than 1, but still positive. We're never going to look at a function with a negative base, because things get wacky when bases are negative. Okay. So number 4. See, number exercise 72. We have g of x equals 1/3 to the x power. So again, it's a base to the x, very basic exponential function. So once again, I'll make a table and plug in the usual 5 inputs that I like. Again, you can plug in other numbers if you wish. -2, -1, 0, 1, and 2. Now 1/3 to the second power, that's 1/3 times 1/3, that's 1/9. I mean, very tiny, but still positive. 1/3 to the first power is 1/3. Right? Anything to the first power is itself. And then 1/3 to the 0 is 1. Right? Remember, any non-zero number to the 0 power is 1. And then we get into negative powers, which again are just the reciprocals of the positive ones. So 1/3 to the -1 is the reciprocal of 1/3, which would be 3. And 1/3 to the -2 would be the reciprocal of 1/3 to the 2, 1/9. Right? And the reciprocal of that is 9. All right, and I got a bunch of points here, and I'll plot them. Oh, you know what? I didn't go to the Desmos site for number 3. Well, I'll do it for this one. All right, so x, y. Inputs are, 1 and 2, and 0, and -1 and -2. And then we got 1, 2, 3, 9. Right. And then, 1/3 say is about here, and 1/9 say, let's say that's about there. I'm just eyeballing things. So we got 0, 1. Cool. But now we have 1, 1/3. So you see, now as I move to the right, it's going down, not going up. 2, 1/9. 3, 1/27, still positive. 4, 1/3 to the 4th, 1/81, still positive. So you're going to see, as I go to the right here, the value of the function will get smaller and smaller, but remain positive. So yet again, we have the x-axis as a horizontal asymptote. The graph will get closer and closer to the x-axis, but never actually touch it. And then as I move left, the graph will go up rapidly. Right? -1, output 3. -2, output 9. Right? And as I move left here, the graph will oops, sorry, that's bad looking. The graph will increase rapidly that way. Right. So one more time, we have for the so you'll notice that for any of these basic exponential function, just a number to the x, simple number to the x power, the horizontal asymptote is the x-axis, is y equals 0, right, the x-axis. All right, but this time they would call this function a decreasing function. All right, as the input increases, the value of the function decreases all the time. All right, so this would be a decreasing function. And the domain and range don't change, right? So the only thing that really changes when the base is less than 1 as compared to when the base is bigger than 1 is that the function is now decreasing instead of increasing. The domain is still all real numbers. The range is still all positive numbers, right? All the values above the horizontal asymptote, right? So from 0 to infinity, but without 0. Right? So again, only thing changing is that it's a decreasing function. Right? Great, and once again, let me go to the Desmos site and verify this. So this was from number 2 I did, exercise 2, 7 to the x. How about, 1/3 to the x power? I guess I don't need the parentheses there. See, 1/3 to the x, and if I make a table with this, see, 1/3 to the -2 is 9, 1/3 to the -1 is 3, 1/3 to the 0 is 1, 1/3 to the 1 is 1/3, or 0.3333333, right? 1/3 squared is 1/9, and you can put in other points. And you see, and I got y equals 0 plotted again as a dotted horizontal line. And as I move to the right, let me zoom in over here, you'll see that the red graph is always above. It doesn't look like it right now, but you zoom in close enough, you'll see that the red graph is always above the x-axis, that purple dotted line. Right? It never touches it, horizontal asymptote. And it's a decreasing function, right? Domain all real numbers, range all positive numbers. Okay, good. So next question. So you're going to see that this is basically going to be the shape of any basic exponential function with a number less than 1 to the x power, right? Or between 0 and 1 to the x power, which we'll see again here. Right, so look at number 5. G of x or y equals 1/7 to the x. So again, this is a basic exponential function, y equals some number to the x power only. And this number is yet again, between 0 and 1, less than 1. So just like all the others, I'm going to make a quick table and plug in the usual, -2 to 2. Now 1/7 to the second is 1/7 times 1/7. That'd be 1/49. 1/7 to the first power would be 1/7. 1/7 to the 0 is 1. And then we get reciprocals, right? 1/7 to the -1 is 7. Right? 1/7 to the -2 would be 49. Right? Okay. Then again, just a rough graph. Right? So we're plugging in -1, -2, +1, +2. And again, here's 1, and let's say there's 7, and again, way up here is 49. It's not perfect. This is not perfect by any means. But we're just going to get a rough shape, right? So 0, 1, then 1, 1/7, right? Tiny. Then 2, 1/49, even tinier. 3 would give me 1/343, even tinier, right? And so as I move to the right, the graph, the value of the function is getting smaller and smaller, but remaining positive. So it'll get as close to the x-axis as you wish, but never actually touch it. So yet again, we have the x-axis as a horizontal asymptote. Alright, then -1 gives me an output of 7, and -2 output of 49, and you see that as I go to the left, it increases quite rapidly. Right. Again, this is a very, very rough sketch. Something like that, right? Alright. So again, once again, this dashed line here that I put in, the x-axis, the graph is never touching that, but it's getting very, very close to it. Right? As close as you want. I'm just going to go HA from here on out. Right? Horizontal asymptote, ha, is y equals 0. Right? The x-axis, as it has always been so far. Right? This may change, right? As soon as this function, the way it looks changes, if we add something or subtract something, that'll move the graph up and down and change the asymptote. But for right now, we're still with the x-axis. And again, we have a decreasing function. Right? As you move from left to right, the function goes down. Right? So a decreasing function. And the domain and range are the same as before. Right? The domain is all real numbers. Right? You can plug in anything you want for x. And the y values are all the positive numbers on this graph. Right? The range is all positive numbers from 0 to infinity, but not including 0. Right, so same stuff as before with question 4. All right, and then we're just going to have one more example with a specific number here that's less than 1, right, between 0 and 1 to just the x power. All right. So number 6, same stuff. So g of x equals 0.6 to the x, or if you like, 0.6 as a fraction would be 3/5 to the x, but still we have a base that's between 0 and 1 to just the x power. So you're going to see that this is going to have a very similar look to numbers 4 and 5, right, where when the base was between 0 and 1 to just the x power. So once again, a quick table with the same 5 inputs that I've been using. So -2, -1, 0, 1, and 2. 3/5 to the second power would be 9/25. 9/25, or 0.36 as a decimal. 3/5 to the first power would just be 3/5, or 0.6. 3/5 to the 0 is 1. And then we get reciprocals. 3/5 to the -1 would be the reciprocal of 3/5 to the 1. So that'd be 5/3, which is 1.6 repeating, right? 1.6666, a little bar over to indicate that it's repeating. 1 2/3. And 3/5 to the -2 would be the reciprocal of 3/5 to the 2, right? So that was 9/25. So this is 25/9. 25/9. Now as a decimal, that would be 2.7 repeating, 2 point, and then 7777777, right? 2 7/9. Okay, and then I'll make a quick graph. Again, my inputs are the same here: 1, 2, 0, -1, and -2. And I'll just go, here's 1, here's 2, here's 3. Okay. Input 0, output 1. Input 1, output 0.6, which is a little more than a half, right? But still less than 1. Input 2, output 0.36, so even smaller, right? And then I plug in 3, it's even smaller, but still positive, right? Still positive. Put 4 in, still smaller, but positive. So again, as we move right, the output decreases, but still remains positive. So still above the x-axis. It just gets closer and closer to the x-axis without actually touching it. So the x-axis is yet again a horizontal asymptote. Alright, then -1 input. Alright, gave me 1 2/3, right? So 1 2/3, so maybe about here. And then -2 for the input was 2 7/9, 2.7-ish, almost 2.8. So a little under 3, maybe there. But you see, as I move left, the value of the function is going up more rapidly. And there we go. And again, a very similar look to numbers 4 and 5. Right. And this one I'll actually go to the Desmos. I know I didn't go to Desmos for 5, but the horizontal asymptote, one more time here, is the x-axis. Right. Again, I'll just do HA for horizontal asymptote. is y equals 0, right, the x-axis. Another decreasing function, right, as x increases, the value of the function is going down always as you move from left to right. Right, another I'll just say decreasing function. And the domain and range are the same too, right? The domain is all real numbers. You can plug in anything you want for x. And the range is just all positive numbers, right? Y can be any positive number, but not 0, right? The output will never be 0. Okay, so after seeing, I'll go to Desmos real quick, put this in. Alright, so here we had 1/3 to the x. How about I get rid of that and make it 0.6 to the x. And again, you're seeing the same stuff. Right? And I can make a table for that. I put a table in. And you're seeing 2.7 repeating for when x is -2. When x is -1, it's 1 2/3. 0, 1, 1.6, 2.36, right? And you see again, as it goes from left to right, it's decreasing. Horizontal asymptote is the x-axis again, y equals 0. Right? Again, you can zoom in as much as you want, and you'll see that the red graph never actually touches the x-axis. Domain's all real numbers, range is all positive numbers. Fantastic. Okay, so after seeing examples 4, 5, and 6, we can make the following generalization. Right, so in general, again, given y equals, or f of x equals, or g of x equals, just some number to the x power, right? The x power only, a basic exponential function with the base between 0 and 1. Right, so like the 1/3 to the x, the 1/7 to the x, the 0.6 to the x that we saw in the previous 3 examples. The graph will look like those 3 graphs did. Right. And again, I'm just going to have 1 and -1 here. So here's 1 on the output. Now b is less than 1. Right, so say b is here. That means that 1 over b, the reciprocal, would be bigger than 1. Let's say it's out here. I'd have the following points, 0, 1, 1, b, right, b of the first, which is less than 1, -1, 1 over b, which is bigger than 1. And it's going to be a decreasing exponential function. Right. So as you move to the right here, the value of the function decreases but remains positive. And as I move left, the value of the function increases more rapidly. So you have a, again, just for these basic functions, number to the x power only, horizontal asymptote is always y equals 0. Right? This line here, the graph will approach but never touch. The function this time, right, with the base between 0 and 1, is a decreasing function. It's a decreasing function. As x increases, y, or the value of the function, decreases all the time. And the domain and range are the same as when the base was bigger than 1. Right? The domain is all real numbers. Right? You can plug in anything you wish for x. The range is only positive numbers. Great. Right, so the same stuff I wrote for examples 4, 5, and 6. Alright, so keep this in your head as well. Right? So we have the case when the base is bigger than 1, looks like that. Just number bigger than 1 to just the x power. And the case when you have a number less than 1 to the x power, looks like this. Right, you should know these. Alright. So now I'm getting into some different powers. All right, so far, every single graph we've had to make has been for an exponential function where the exponent was just x. But that's not always the case. All right, so here, now in the next section of exercises, I'm asked to graph each function in the same coordinate system. All right. So we have f of x equals 3 to the x. I'll do that in red. And g of x equals 3 to the x minus 1. See, the power is not just x anymore. It's x minus 1. And we'll see what happens to the graph, right? Because they both have the same base. Right? Both of these have a base of 3. Just the exponents are different. Right? And we'll see how the graph gets changed. All right, now we already graphed this one earlier. F of x equals 3 to the x. Let's put in some values here. There's 3 and there's 9. We plugged in, 1 and 2 and -1 and -2. Alright, so you had, 3 to the 0 is 1. 3 to the 1 is 3. 3 to the 2 is 9. 3 to the -1 was 1/3. Alright, so I'm going to say that's 1/3 here, and then 1/9, right? Real tiny. I'm sorry about how tiny that is. 3 to the -2 is 1/9, right? Even smaller. And here was this graph. Right? We saw this before. We saw this before. All right, now I'm not going to write out all the properties this time. But notice again, the x-axis is the horizontal asymptote. It's an increasing function. Domain's all real numbers. The range is all positive numbers. All the same stuff I wrote before. Now, this next graph. Let's do this over here. Right? I'm going to make another table. It's a different power, right? It's not just to the x power anymore. So instead of putting in -2 to 2 like I used to, I'm going to plug in a value. I'm going to start at what value of x gives me 3 to the 0, and then I'll go 2 above that, 2 below that. Watch this, right? So obviously if x were 1, I'm going to put this in the middle. If x were 1, you'd have 3 to the 0. All right, 1 minus 1. And then I'll plug in 2 integers below this, 0 and -1, going lower than 1 and then going higher than 1, put in 2 and 3. So I'm going to plug in -1 to 3. So if I plug in 3, right, that'd be 3 squared. 3 minus 1, that's 9. If I plug in 2 for x, that's 3 to the 2 minus 1, that's 3 to the 1, that's 3. Plug in 1, you get 3 to the 0. 1 minus 1, that's 1. Plug in 0, you get 3 to the -1, which would be 1 over 3. And if you plug in -1, you get 3 to the -2, which would be the reciprocal of 3 to the 2, which is 1 over 9. So you see, all it does is shift the points from this original graph to the right 1 unit. So I got, instead of 0, 1, I got 1, 1. Right, that's just 1 unit to the right. Instead of 1, 3, there's 2, 3. Right, 2, 3. Instead of 2, 9, like on the original graph, there's 3, 9. 3, 9. Instead of -1, 1/3, now there's 0, 1/3, right? 0, 1/3. Just 1 unit to the right. Instead of -2, 1/9, it's -1, 1/9. Right, so right here. All right, so this graph is always below. I know it's going to look like they're touching here, but this graph I'm drawing here is always below the red graph. Oops, should make that a little. Right. like that. All right, so here's the, again, the red graph is the graph of function f. This green graph is the graph of function g. All right. Notice all this, changing x to x minus 1 just shifts the graph to the right 1 unit. Changing x to x minus 1 shifted the graph to the right 1 unit. And that's really all we're going to see. Right? That's all we're asked to do. They both have the x-axis as a horizontal asymptote. They're both increasing. They both have a domain of all real numbers, and they both have a range of all positive numbers. Right, so all that happened was a shift to the right 1 unit. Great. And again, I'll put these up on Desmos here. Let me go back here. We had, one function was f of x equals 3 to the x. And the next function they gave us was g of x equals 3 to the x minus 1. Should be in the power here. Come on. 3 to the quantity x minus 1 to keep that in the power. And I'll change colors. And I know some people are colorblind out there. I apologize. But yeah, see that all the next graph is just 1 unit to the right of the original. Same horizontal asymptote. They're both increasing. Both have a domain of all real numbers. Both have a range of positive numbers. Right. Great. All right. Next question. Same instructions. We're asked to graph both of these on the same coordinate plane. So f of x equals 2 to the x. Right? The base is bigger than 1, right? So this is going to be increasing. And then g of x equals, not 2 to the x, but 2 to the x plus 2 power. All right, so again, the first graph I'll do in red, the next one I'll do in green. All right, so the first graph, I'm plugging in the usual values, -2 to 2. Now for f, right, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the -1 is, 1/2. Right? You got 1/2 and 1/4 here. Right? 2 to the -1 would be 1/2. 2 to the -2 would be 1/4. All right, and here's the graph of f. Right? Once again, an increasing function, always going up as I go left to right. The horizontal asymptote is the x-axis. Yet again, the domain's all real numbers. The range is all positive numbers. Right? So there's f. All right, and then like I did with the last example, I'm going to make a little table for g. We have input x, output g of x. All right, and then once again, I'm going to think, what value of x would give me 2 to the 0 power? Well, if x were -2, right, -2 plus 2 is 0. And then I'll go 2 integers below that, -3, -4, and then 2 integers above that, -1 and 0. All right, so for this, I'm plugging in 0, -1, -2, -3, and -4. Right. Let's plot these points. Now what we're going to see, you're going to see that the graph of g is always above the graph of f. Watch this. All right. If I plug in -2, that's 2 to the 0. That's 1. Plug in -1. That would be 2 to the first. That's 2. Plug in 0 for x. That'd be 2 to the second power. That's 4. And then plug in -3, you get 2 to the -1, which is 1/2. Plug in -4 for x, you get 2 to the -2, which is 1/4. Right? So you're going to see all of these points are just 2 units to the left of the points on the original graph of f. So you got -2, 1 instead of 0, 1. See, 0, 1, move left 2 units, and you got a point on the graph of g. -2, 1. Got -1, 2. right, instead of 1, 2. These are 2 units apart. 1, 2 and negative 1, 2. Instead of 2, 4, I've got 0, 4. 0, 4, y-intercept. 2 units to the left. Instead of negative 1, 1/2, I have negative 3, 1/2. Right? Negative 3, 1/2. Instead of negative 2, 1/4, I have negative 4, 1/4. 2 units to the left, 2 units to the left. So yeah, so this graph of G is always above the graph of F, but just, there's G. 2 units to the left. And the graph will approach, the x-axis as well. It'll, as I go left, it's still positive, just smaller and smaller and smaller. But yeah, hopefully you noticed that when I replaced x with x plus 2, it just shifted the original graph left 2 units. Right. Still got the x-axis as the horizontal asymptote. They're both still increasing functions. They both have a domain of all real numbers, and they both have a range of all positive numbers. Great, and again, you can put this up on Desmos if you wish, but I'm going to not do that now. Okay, now, next question. So far, every single function has had the x-axis as a horizontal asymptote. But what we're going to see in this problem is that when you add or subtract the number after the function, after the exponential part, 4 to the x here, if you add or subtract something to that, that's going to move the whole graph up or down, meaning the horizontal asymptote will also move up or down that many units. Alright, so same instructions, right? We're asked to graph both of these on the same set of axes. Alright, now f of x equals 4 to the x. I'm going to plug in the, that's the basic b to the x, right, where the base is bigger than 1. So I'm going to plug in the usual, 0. Actually, you know what? I'm just going to go, just because I don't want to go 4 squared is 16, I don't want to put in 16 units here. I'm just going to go 0, 1, and negative 1, because you should know how these look now. And then 1, 2, 3, 4. And then here's 1/4. Alright, when I plug in 0, 4 to the 0 is 1. 4 to the 1 is 4. 4 to the negative 1 is 1/4. Right, and this will be one of those, you've seen these a bunch. One of these increasing functions with the graph approaching the x-axis to the left here. Right, the x-axis is the horizontal asymptote. So there's the graph of f. Now for G, it just takes the graph of f. It takes 4 to the x, same thing as for f. And then you're just adding 2 to everything. So instead of 0, 1, you'd have 0, 3. 2 units above. And instead of 1, 4, you'd have 1, 2, right? 4 to the first is 4, plus 2 is 6, 1, 6. So instead of 1, 4, now we're at 1, 6, just 2 units above. And instead of negative 1, 1/4, I'm at 2 and 1/4. Which would be 9/4, right? 9/4, 2 and 1/4. So negative 1, 9/4 right there. And instead of, for the graph of f, right, this is y equals 0. Y equals 0 is the horizontal asymptote. But move that up 2 as well, right? Everything gets moved up 2 with this plus 2 afterwards. So now, a dotted line here at y equals 2. I'm definitely going to put this on the Desmos site. Y equals 2 is the horizontal asymptote for function g. Right, so g looks like this. It looks exactly the same as f. Right, so my hand drawing is not great, because it should look exactly the same as f. just moved up 2 units. All right, there's G. All right, and let me show you this on the Desmos site. All right. So we had f of x was equal to 4 to the x, and g of x was 4 to the x, and then after that plus 2. Right, and then I'll put in y equals 2 as a dotted line. Right, and you're going to see that as an asymptote for that function. Right. See, look. The red graph, the green graph has the same exact shape as the red graph, just everything's up 2 units. And look, I zoom in, the green graph is gets closer and closer and closer to y equals 2, but never actually touching it. Right, that green graph, if you zoom in far enough, doesn't actually touch y equals 2. Right, y equals 2 would be the horizontal asymptote for that function. Okay, wonderful. All right, hopefully that made sense. All right, and then something very similar in the next question, where some basic exponential function, b to the x, is has a number added to it or subtracted from it. So here we have f of x equals 2 to the x, basic, right, number to the x power that you've seen a bunch of. And this takes the same function, 2 to the x, but then afterwards just subtracts 1. Right? So that plus 2, that moved everything up 2. What we're going to see here is that the minus 1 is just going to move everything down 1. Right, so again, I'll graph these on the same set of axes. All right, the basic 2 to the x, I'm going to plug in 0, plug in 1, and plug in negative 1. And again, you should know how these look by now after all these examples. Then the output of 1, output of 2, you got a half here, and let's see, everything's going to be moved down 1, so here's negative 1, here's negative half. Right. Cool. All right, now for the original, for function f, 2 to the x, right? 2 to the 0 is 1, so that has 0, 1 on it. 2 to the 1 is 2, so 1, 2. And 2 to the negative 1 is a half. All right. And remember that for all the basic functions, b to the x-axis is the horizontal asymptote. So the graph is going to look like this, being an increasing function, and have the x-axis as its horizontal asymptote. Right? Get closer to the x-axis without actually touching it. So there's a graph of f. All right, and then all g does is take f, 2 to the x, and then subtract 1 from all the outputs. Right? So instead of, when you plug in 0, 2 to the 0 is 1, minus 1 is 0. Instead of 0, 1, you're down 1 unit, 0, 0, the origin. Instead of 1, 2, you got 1, 1. Just go down 1. Right, 2 minus 1. Instead of negative 1, 1 half, you'd have negative 1, negative 1 half. Right, 1 half minus 1, negative 1 half. And then instead of the x-axis, y equals 0, being the horizontal asymptote, now for the graph of g, just move that down 1. Make another dotted line here at y equals negative 1. Right, there's y equals negative 1. There's the horizontal asymptote for g, right, for function g. And it should have the same exact shape. So again, this is a hand drawing, probably not going to look perfect, but should have the same exact shape as f. All right, there's g, and then again the line y equals negative 1 is now the horizontal asymptote. The graph will be approaching that line without actually touching it. All right, and again, I'll show you with the Desmos site. So we had f of x equals 2 to the x, and then g of x was 2 to the x minus 1. And y equals 0 was the horizontal asymptote for f. And here I have y equals -1 as the horizontal asymptote for g. And you can see that, right? That blue dotted line, right? The green graph is g. See, it's getting closer to that blue dotted line without actually touching it. Fantastic. Okay, next question. Now we're going to be back into graphing just one function. Right, just one function. And again, I'm just going to make a table with a few points, and we should, based on our knowledge now of exponential functions, we should have a rough idea, where the horizontal asymptote is and if it's increasing or decreasing, all that junk. So number 11, exercise 86, we have f of x equals, not just 3 to the x, but 3 to the x minus 2 power, right? The minus 2 is up here. Remember, if the minus 2 or plus 2, if it's in the power, that moved the graph left and right. If I had minus 2 after, if it was 3 to the x, if it was like this, if it was 3 to the x and then minus 2 after, that would move the graph down 2. Right? But it's not that, right? It's not that, so I'm not worried about that. All right, so same deal. Like, I'm going to make a little table, x, f of x. And as I mentioned before, I like to plug in a value of x that makes the power 0. So that'd be x equals 2. I'm going to put that in the middle. And then just go back to 1 and 0, and then go forward 2 integers, 3 and 4. All right. If I plug in 2, 3 to the 0 is 1. Plug in 3, you get 3 to the 1, which is 3. Plug in 4, you get 3 squared, which is 9. Plug in 1, you get 3 to the -1, which is 1/3. Plug in 0, you get 3 to the -2, which is 1/9, and so on. Right? And again, making a rough sketch here where I'm plugging in 0, 1, 2, 3, and 4, and have outputs of 1, 3, 9. Right? Extend this here, okay, and 1/3, 1/9, a little tiny. All right, so plugging in 0 gives me 1/9. Plugging in 1 gives me 1/3. Plugging in 2 gives me 1. 3 gives me 3. And 4 gives me 9. Right. Just eyeballing it. And notice, again, there is nothing added or subtracted from this. Nothing added or subtracted after the exponential function. So the horizontal asymptote is still going to be the x-axis. Right? So it's still this increasing function, as we expected, I would hope, with the x-axis as the horizontal asymptote. And the domain is all real numbers. The range is all positive numbers. Right. Great. And you can punch that in your Desmos calculator too and check it out, see if it looks good. Right. Next question. So I've got your basic exponential function, 2 to the x, but then afterwards there's this -3. So that's going to move everything down 3. Right, so let's just do this here. Right, so I'm going to plug in the usual, right, because the power is x. I'm just going to start with 0 and then go 1 and 2 and -1, -2, just like the usual. The only difference is, though, instead of the horizontal asymptote being the x-axis, the horizontal asymptote is going to be down 3. All right, I'll make that a dotted line. This line here. Y equals -3. So that'll also change the range. I haven't discussed that yet. But y equals 3 is the horizontal asymptote for this. Y equals -3 is the horizontal asymptote for this function. Alright, so let me plot some points. 2 to the 0 is 1. -3 would be -2. So you have 0, -2. And you can make a table if you want. Plugging in 1, you get 2 minus 3, which is -1. So 1, -1. Plug in 2, you get 4 minus 3, which is +1. Right, so I should have +1 here. So 2, 1. Alright, plug in -1, you get a half minus 3, that's -2.5. So about here, let's say. and plug in -2. 2 to the -2 is a quarter. Minus 3 is -2 3/4. -2 3/4, so lower. But you see that the graph will be approaching the line y equals -3, without actually touching it. And it's still this increasing function. All right, but this time I'm going to write out something that's a little different, right? So it's still increasing. Right, it's still increasing, going up forever as you go from left to right. The domain is always, all real numbers for all these exponential functions, but the range has changed. All right, the range is not just all the positive values, right? But now it's all the values above -3. See, all the y values above -3 are used in some point. So we're going from -3 to and up, right? -3 and up, but not including -3, right? Y equals -3 is not actually hit. So the range changes when you're adding or subtracting some number after the function. Right? So please keep that in mind. The range changes when the asymptote moves. Okay, next question. All right. So f of x equals 1/2 to the x minus 3. Notice it's a basic function, number to the x power. But then you have this again minus 3 afterwards. This will move everything down 3. So again, I'm going to just make a x, y, and let me just go down 3 here. Instead of the horizontal asymptote being the x-axis, it's going to again be this line here, right? Dotted line. Y equals -3. That's the horizontal asymptote for this function. And since it's just half to the just x power, I'm going to plug in the usual, 0, 1, and 2, and -1 and -2. Right. And let's see what we get. All right, now half to the 0 is 1, minus 3 is -2. All right, so input 0, output -2. 1/2 to the first is a half. Minus 3 is -2.5, so lower than -2 here. So this point here, when input 1, output -2.5. Input 2, 1/2 squared is a quarter. Minus 3 is -2 3/4, which is even lower. So you're going to see that the graph approaches y equals -3 to the right. This is a decreasing function, right? Which you could have guessed because the base is less than 1. And then 1/2 to the -1 is 2, minus 3 is -1. So -1, -1. And then 1/2 to the -2 is 4, minus 3 is +1. So -2 input, +1 output. All right, and then I get the rest of the function drawn in here. Yeah, it's a decreasing function. Decreasing this time. The domain is once again all real numbers, as it is for all these exponential functions. But the range changed, right? The range is not just the positive numbers, it's all the numbers above -3, right? So from -3 to infinity, but not including -3 there. Okay, great. Again, you can punch this in Desmos or some graphing calculator and check. Okay, great. All right, now the next question introduces you to a number that you may or may not have seen before. I mean, obviously, if you've seen it before, it's not an introduction. The number e. All right. Now, e in mathematics. It's a symbol like pi. All right, you remember pi? All right, pi is equal to 3.14159. It's one of those irrational numbers where the decimal goes on forever and no pattern repeats forever. E is like that. Okay, so E, I'm just going to tell you what the value is, the first several decimal places. It's 2.718281828459045. This is how much I remember from our time in school. But as long as you know that E is approximately 2.7, I'm cool with that. All right. So this number E, and it's called the natural base sometimes. All right, this number E, this is called the natural base. For reasons you'll understand much more when you go into it and take a calculus course. So I'm not going to get into why it's referred to as the natural base right now. But all I want you to do is know the value of E is about 2.7. Okay, or 2.718, just at least a couple decimal places. All right, so that's bigger than 1, right? That's bigger than 1. So if this was just e to the x, or if it was just e to the x, you'd know exactly what it looked like. It'd be this, an increasing function, right? You have a number bigger than 1 to the x power. But then you got this minus 2 here, right, in the power. That's going to shift it to the right 2 units. All right, so here's what I'm going to do. I'm going to make a little table, x, f of x, and I'm only going to plug in a few values. I'm going to plug in the value of x. That gives me 0 as a power, e to the 0. So that's x equals 2. And then I'm just going to plug in 1 and 3. So 1, 2, and 3. Right? And that should be enough to be able to make a rough sketch of this graph. X, y, 0, 1, 2, 3. And here's 1, 2, 3. E is about here. Right, again, it's approximately 2.7, somewhere between 2 and 3, closer to 3. And then 1 over E, right, 1 over E would be a little bigger than a third. So let's say so about here, let's say. Less than a half, but a little bigger than a third. Between a half and a third. So there's 1 over E. Right? 1 divided by E, e to the negative first. Right, when I plug in 2, I get e to the 0. Remember, anything to the 0 power, except 0, is 1. And then I plug in 3, that'd be e to the first. Right, e is approximately 2.7. Right. And then e to the 1 minus 2, e to the negative first, that's 1 over e, which I'll pull up a calculator. Again, I know it's between 1/3 and 1/2, right, between 0.3. Let me pull up a calculator and do 1 divided by e. 1 divided by, and then e is actually just above the division sign here, second e. It's about 0.3, see, between a third and a half, 0.3678, 0.37, round to 0.37, or if you were rounding the nearest tenth, that would round to 0.4. Right. So that's all I wanted. Right. This is approximately 0.4, right, 0.37. Yeah, so got those values here, and then I plot them. 2, 1, 3e, 1 over e, and then notice again, there is no number added or subtracted after the exponential function, so the horizontal asymptote will be the x-axis. Right? This is an increasing function with the horizontal asymptote of the x-axis. Right. It'll never hit the x-axis. Great, so the domain's all real numbers, range is all positive numbers, and it's an increasing function. Wonderful. Again, the key thing to take away from this page is this number e. You're going to see it a lot, again, especially if you go into a calculus course. E is 2.7-ish, right? It's about 2.7. Please know that. All right, and I got just one final question, which kind of combines a bunch of function transformations. So I have f of x equals 2 to not the x power, but the negative x power minus 1. So this negative in front of the x changes everything. If it was 2 to the x, right, remember if it was 2 to the x, the graph was increasing, right, something like that. What you're going to notice, what you're going to see is that 2 to the negative x flips that around. It makes it decreasing. So we're going to see that this is actually going to be, I know the base is 2, I know the base is bigger than 1, but it's not 2 to the 1x, it's 2 to the negative 1x. That, again, that changes everything, that flips it. Makes it go from increasing to decreasing. And you'll see when I plot the graph of this thing. Alright, so let me make a table. Alright, and again, I like to plug in the value of x that makes this 0, which would be negative 1. And then I'll go 2 below that, negative 2, negative 3, and 2 above that, 0 and 1. So I'll plug in these 5 values. Now, 2 to the 0 would be 1, minus 1 would be 0. You'd have an output of 0 with an input of negative 1. When I input 0, you'd have 2 to the negative 1, which is a half. A half minus 1 is negative half. See how it's getting smaller as I increase the input? It's getting smaller, so the value is decreasing. This is going to be a decreasing function. Plug in 1, that'd be 2 to the negative 2. 1/4 minus 1 would be negative 3/4, right? Even smaller, even lower. Okay, and then plug in negative 2, you get positive 2 minus 1. You get 2 to the first is 2, minus 1 is 1. And then input negative 3, you get 2 squared is 4, minus 1 is 3. Right, so I got a bunch of ordered pairs here. I'm going to make a rough sketch. Now, just like I've done in previous questions, see this minus 1 after the exponential function? Right, minus 1. Remember, that's going to bring everything down 1. So instead of the horizontal asymptote being the x-axis, as it usually is for a basic exponential, it's going to be down 1. So let's say minus 1 here. I'll put a little dotted line in here at y equals negative 1. Right, this is going to be the horizontal asymptote, right, HA. The graph will approach this line without actually touching it. Alright, and I plugged in, positive 1, 0, negative 1, negative 2, and negative 3 in my table. Outputs were 0 and 1 and 3. And here's negative 1/2. Here's negative 3/4. Alright, now I can plot my points. Negative 1, 0. So there's an x-intercept here. 0, negative 1/2. 1, negative 3/4. Right, and you see as I move to the right, the graph will be, the value of the function is decreasing toward the line y equals negative 1, right? When it won't actually touch it. You're never going to hit the line y equals negative 1. Alright, and then negative 2, we got output of 1. And negative 3 gave me an output of 3, positive 3. And it goes up more rapidly going this way. Alright, and there's your function, your exponential function. So yeah, it's a decreasing function. Domain's still all real numbers. That doesn't change no matter what you do to your exponential, no matter how you make it look. The domain is still all real numbers. But the range is different. Right? The range is affected by this minus 1. Right, everything got shoved down 1 unit. So the range is, not just positive numbers, but all the numbers above -1, right? So from -1 to infinity, but not including -1, right? The y value of -1 is never reached. Fantastic. All right, so just be aware of, if it's not just a number to just the x power, if there's other stuff happening like there is here, just, pay attention to plotting your points correctly and how it'll affect the look of the graph. Great, and that's it. That's all I got. Hopefully watching me do these 15 questions here helps you in some way when you're asked to graph some exponential function on your own. And thank you very much for watching.